Welcome to This Explainer. Today, we're jumping straight into something absolutely crucial for modern development: how to safely integrate AI capabilities directly into your Spring Boot applications. Look, we already know how to build rock-solid backends with our controllers, services, and repositories, but the exact moment you drop artificial intelligence into the mix, the complexity literally skyrockets. Suddenly, you're faced with connecting model intelligence to your real, sensitive application data and operations, and you have to figure out how to do all of that without handing over the keys to your domain. So how do we solve this? Well, we rely on a framework called AI Fabric. Think of it as the essential bridge connecting your existing battle-tested domain logic to these powerful AI models. And to be clear, we are not just talking about bolting on a generic chatbot UI or spinning up a standalone vector database. No, AI Fabric is a modular Java and Spring Boot framework that sits right inside your application. It hands you explicit contracts to safely orchestrate everything, from data retrieval and generation to executing actions and locking down privacy. Here is our roadmap for today. We'll start with the AI integration problem, then introduce the AI Fabric architecture, and define the strict ownership boundary. After that, we'll cover retrieving safe searchable evidence, governed actions, and memory, and wrap up with enforcing security and privacy. Let's get into it. All right, kicking things off with Section 1, the AI integration problem, or as it usually feels in practice, the chaos of unmanaged AI. If you just try to wire an LLM straight into your app without a proper boundary, it might work on day one, but it rarely stays simple. Without a solid architecture, you inevitably end up with what I call spaghetti AI. We've all felt the pain of this, right? Your state is scattered everywhere, your code is fragile, and security feels like an afterthought. You've got one controller calling a model SDK, some random service formatting prompt strings, and user confirmations hanging out entirely in the UI state. Even worse, you might find yourself trusting a tenant ID sent directly from a browser. Each little shortcut might seem fine in isolation, but stitch them all together and your AI workflow is practically impossible to secure. So let's fix that. Moving right along to Section 2, Introducing AI Fabric Architecture, specifically, its 5 layers. What makes this approach so incredibly reliable is how it forces sanity back into your codebase. Simply put, AI Fabric is the missing orchestration layer. It's the guardrail that keeps you from blindly trusting a language model with your database. It ensures your Spring Boot application always remains the absolute source of truth. AI Fabric coordinates the messy stuff, like extracting user intent and preparing your prompt contexts, but it leaves the actual domain side effects entirely in your control. A natural language request actually travels through these 5 ordered layers. It starts at the HTTP entry point, where your Spring Boot application securely handles authentication. Then, AI Fabric steps in to coordinate the workflow, handling retrieval and privacy controls, all while passing through abstract provider contracts. Only at the very end of this chain do the concrete systems, like OpenAI, local Onyx models, or Lucene, actually perform the inference and persistence. Now, on to Section 3, the strict ownership boundary, basically establishing who exactly controls what. To make this architecture truly safe in production, you cannot treat model output as authority. You have to build a fail-safe system. Here is the golden rule. Your application always owns the business truth, while AI Fabric strictly owns the AI coordination. An LLM can propose a parameter or guess what a user wants to do, sure, but it never, ever directly owns a repository right. Your browser can show a pretty confirmation button, but it doesn't manufacture the action intent. Your app handles the business rules, AI Fabric handles the complex orchestration. This all comes together in the orchestration pipeline. Think of it like a strict state machine. Any single step can terminate the whole workflow with a controlled, safe result if a boundary gets breached. It starts with the user's raw query and carefully accumulates processed intents and routing logic. Because this pipeline is strictly ordered, your security and access controls are fully executed long before the LLM even catches a glimpse of the prompt. Let's dive into Section 4, Retrieving Safe Searchable Evidence. This is all about creating your vectors safely. Because just saving a record in your database doesn't mean it's magically safe to index for AI search, right? You need to turn application records into evidence without leaking internal data. These 4 exact steps guarantee that your database save operation is completely separated from the AI indexing process. Your domain record probably has fields the AI should never see. So we create an AI-facing projection, generate an embedding for only the approved text, and then persist that vector with stable metadata so we don't lose its identity. This is deliberate data minimization in action. You use configurations like an AI searchable annotation to explicitly declare exactly what text should contribute to semantic meaning. Everything else, like private fields, tenant IDs, or internal document categories, stays completely invisible to the vector index. All right, Section 5, Governed Actions and Memory. Let's look at state beyond the TER. So how do we handle a user asking the AI to actually change data in your app? We use governed actions. Remember, the LLM is just guessing intent. It is not executing code. AI Fabric will not just run any method that sounds remotely like the model's output. Instead, it checks that intent against a strict allow list in the AI action registry. It parses the proposed values into actual strongly typed Java objects and strictly evaluates your app's permission policies before executing a single thing. And this gives us a brilliant two-turn confirmation loop. Turn 1 extracts the intent and stops. Turn 2 gets the user's yes. Turn 3 executes. But here is the critical part. That pause happens entirely on the server side. A user manipulating a button in their browser can never force an unauthorized execution because we just don't trust the UI to send the action back to us. Instead, we hold a pending action securely in the backend chat session. This completely prevents the system from confusing some incomplete AI draft with a fully authorized user command. When the user clicks yes, AI Fabric resolves that confirmation against the trusted backend state, makes sure it hasn't expired, and only then lets your application execute the change. Which brings us to our final core topic, Section 6, Enforcing Security and Privacy. Setting up gates before generation. This is where zero trust principles crash head-on into AI workflows. You see, an LLM simply cannot unsee private data. It can't repair a boundary once you've broken it. So these framework gates must run and filter the context before the language model even wakes up to evaluate the request. AI Fabric steps in to aggressively mask sensitive inputs, like scrubbing out a social security number, and applies strict tenant filters to your vector searches. Only perfectly sanitized, permitted data ever makes it to the generation provider. If you look at this failure matrix, you'll see a well-designed architecture always fails closed, prioritizing data isolation above all else. But listen, we don't just rely on good intentions here. A huge part of safely testing and shipping AI Fabric workflows is proving this matrix works using 4 strict evidence classes. First, we use deterministic tests to validate our backend logic in state machines entirely independent of the LLM. Second, we run packaged application smoke tests to verify the integrated runtime. Third, we use Docker vector contracts to securely test our isolated database queries. And finally, we run key live provider tests to ensure the actual LLM endpoints behave precisely as expected. We rigorously prove, at every level, that data leakage simply never happens. And at the heart of that fail-closed system is the entity access policy. This forces you to securely derive identity on the backend. No more blindly trusting whatever tenant ID the client's browser decided to send over. You implement this as a strict allow policy, granting operations only for known subjects, and outright denying missing identities, unknown resources, or cross-tenant attempts. So, as you go back and evaluate your own systems, I want you to ask yourself a tough question. Are you just hoping the AI behaves, or have you actually built a framework that guarantees it? By embracing explicit boundaries for retrieval, governed actions, and memory, AI Fabric ensures your Spring Boot application always stays firmly in charge. Thanks for exploring this architecture with me, and I highly encourage you to start mapping your own AI requirements against these exact secure boundaries.